In this video, I'm just going to do the part B of the question. In the part B, the question is asking to find out if R1 is equal to 10 kilo ohm and find R2. That result in AF is equal to 10 voltage per voltage for the following three cases. A is equal to 1000 voltage per voltage, A is equal to 200 voltage per voltage, A is equal to 15 voltage per voltage. Okay, so here AF is nothing but a closed loop gain, and closed loop gain is defined as, let me use a new page for it. Closed loop gain, that is expressed as AF, and that is defined as A over 1 plus A times beta. Now here they have mentioned that AF is equal to 10 voltage per voltage, so that's the closed loop gain. And then they are asking us to find out R2 value. Now here we have this expression, we have nothing related to R2, but if you watch my previous video, I derived an expression for the beta that is equal to R1 over R1 plus R2. That is also in the first part of the question. They also ask us to derive this expression. We derive from scratch. If you watch my previous video, this is the A part I did. You can see how did you derive it. So we know that beta is equal to R1 over R1 plus R2. Okay, beta is equal to, let me note that down right here. Beta is equal to R1 over R1 plus R2. So if I calculate beta from this, because I know the AF, that is 10 provided, and then they are giving the A value as well, that is 1000 voltage per voltage. So we have that one also available here. So I'm doing the first part of it because there are three different A's. In the first part they provided it to be 1000, so I put 1000 here, and then 1 plus 1000 beta. So here we have to calculate the beta. If you rearrange and calculate the beta, you will end up getting 0.099. And then after you calculate the beta, you have to plug it in this equation. Now we know the beta, that is 0.099, and they have given the R1 resistance, that is 10 kilo ohm. Then they are asking for the R2. So we have only one unknown variable, so it's easy to solve. So this is 10k divided by 10k plus R2, and if you rearrange and solve for R2, we will end up getting R2 to be 91.01 kilo ohm resistance. Okay, so this is for the first part. First part we calculate the beta R2, but R2 is the main thing, and we did it right here. And let's look at the part 2 of it. In the part 2, there's nothing different. They are asking the exact R2 value, but now the A is the only different thing. So it means we have to just plug it in the same equation. AF is equal to A over 1 plus A beta, and here AF is always 10, and A value is in this case 200, so we have to plug 200 for it, and then 1 plus 200 beta. This is part 2 we are doing. And if you rearrange and solve for beta, you will end up getting 0.095. And once you have beta, we know that beta is equal to R1 over R1 plus R2. And since we know beta, we can plug it right here, 0.095. That is equal to R1 is 10k ohm resistance over 10k, and R2 is what we are trying to find. And if you solve for R2, you will end up getting 95.26 k ohm resistance. Okay, this is for the part 2. And part 3, in the part 3, exact same thing. AF is equal to A over 1 plus A times beta. In this case, in the part 3, the A is 15, so we put AF is always 10, and this is 15, 1 plus 15 beta. Solve for beta, you will end up getting 0.0333 for this. And once you have beta, we know that beta is equal to R1 over R1 plus R2. We plug the beta, that is 0.0333 right here, and then R1 is known to be this is equal to R1 is known to be 10K, plug that in, and then R2 is what we are trying to find. If you rearrange solve for R2, you will end up getting 290.3K ohm resistance. And that is basically it. Those are the three different R2 for three different A values. And that's it for this video. I hope you guys found the video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.